Your app is working perfectly. You shipped it, your 10 beta users love it, the P99 latency is beautiful, and you're feeling good about your career choices. Then you get a mention on Hacker News. And then the database melts. In today's video, we're going to find out exactly why this happens, not in a vague, think about scale early way, but in a specific, mechanical, your code is doing this right now way. It is May 14th, 2026, and you're watching Runtime. When 10 users hit your app, everything looks linear. One request comes in, your server handles it, a response goes out. Neat and tidy. But software at rest and software under concurrent load are two completely different programs. The bugs you have at 10 users are functional bugs. The bugs you have at 10,000 are physics bugs. The first thing that dies is almost always the database. Not because your queries are wrong, they passed code review, they have indexes, they look fine. They die because at 10 users you have 10 concurrent connections. At 10,000 users, you have 10,000 concurrent connections, and your Postgres instance has a default connection limit of 100. The rest are queued. Then the queue fills. Then requests time out. Then your users get a white screen and assume you're a scam. Before the connections even saturate, there's a good chance an n+1 query is already eating your database alive. You fetch a list of 100 posts. Then for each post, you fire another query to get the author. That's 101 queries. At 10 users, that's invisible, maybe 50 milliseconds total. At 10,000 users, 101 queries firing in parallel across thousands of requests is a full table scan happening continuously, on loop forever, until someone pages you at 2 am. Here's one I've hit personally. I built a feature that stored session state in a dictionary and application memory, fast, simple, zero dependencies. It worked perfectly across months of testing. The moment we went live with real traffic, we had 6 load-balanced instances and users were randomly losing their sessions because their next request hit a different server that had no idea who they were. The data was correct on exactly one machine, which is a great way to experience distributed systems for the first time against your will. Most apps are written synchronously end-to-end. Request comes in, we do work, we respond. That's fine when the work is fast. It is catastrophically bad when the work involves sending an email, calling a third-party API, or resizing an image, because now every request is blocking a thread while it waits for something that could be done asynchronously in the background. At 10 users, you don't notice. At 10,000 users, all your threads are stuck waiting for Stripe to respond, and new requests have nowhere to go. You did the right thing. You added Redis. You cache the expensive query result for 60 seconds. This works beautifully until the cache entry expires at the exact moment 500 simultaneous requests arrive. All 500 see an empty cache. All 500 go to the database at once. The database falls over. The cache fills with nothing because the query's timed out. And now you have a stampede on a loop. This is a real failure mode with a real name, Cache Stampede. And it has taken down production systems at companies that definitely knew better. Here's what the design for scale from day one crowd leaves out. Almost all of these problems are genuinely premature to solve at 10 users. Connection pooling, message queues, distributed caches, async workers, these are operational complexity you have to maintain forever. If you add them before you have load, you've spent real engineering time solving a problem you might never have. The honest version of this advice isn't always build for scale. It's know exactly which failure mode will hit you first. So when traffic arrives, you fix the one right thing instead of everything at once. Your app isn't broken. It's just honest. At 10 users, it tells you what you built. At 10,000 users, it tells you what you assumed. The gap between those two things is the actual architecture of your system. This has been Runtime. Thanks for watching, and I will see you in the next one.